Okay, please turn to the very back side of your notes. And as you see here, I have 2 sheets of paper. This is what you get to use on your test. I will give you all the formulas. This is a nice sheet of a collection of all sorts of different formulas you use. This is the dreaded unit. This is the unit where sometimes people don't do very well. And yeah, so it'll be the first test of fourth quarter, so it's good motivation. Try to start off on the right note. Make sure you got your act together. This is not the unit you want to procrastinate through. This test is sometimes the end of people's grades, so it's only downhill from there sometimes. So got to get your act together. Yo, I'll take us. I think this unit is usually about 14 days in length, so we're talking roughly about a 3-week period. So um, that's where we're at. So what we want to do is we want to focus on this page today, and you need to know that tangent is sine over cosine. Did you know that? Did you know that cosecant is 1 over sine? Did you know that secant is 1 over cosine? And did you know that cotangent is cosine over sine? So what's nice to know is that all trigonometric functions can be written in terms of sine or cosine. We're going to use that to our advantage, okay? So we flip back to the first page, and I'm going to do a nice simplifying process here. It says simplify the following. You will want for me to tell you a way to do these problems as like, this is what you always do. And I can't do that. I can't do that, okay? It's kind of like factoring. Factoring this is different than factoring that, correct? And that's just something you have to recognize and say, well, I kind of see how this is paired up. So we're just going to have you practice this stuff, and as we do many examples, you'll get better at it. So the first technique to simplifying is to turn things into sine and cosine. This is already in terms of sine, so I'm not going to change that. So I'm going to write it as sine of theta over 1 times secant is not in terms of sine or cosine, so I'll rewrite it as 1 over cosine. And I get sine of theta over cosine. Hey, look at that. What is sine over cosine? Tangent. So this simplifies to tangent of theta. So sine times secant is theta. It's pretty straightforward, huh? So that's a nice example. Let's try the next one. Cotangent times sine. So I'll write this as cosine of theta over sine of theta times sine of theta over 1. Yeah. Yep. So if you don't know these, it's time to really start to commit this stuff to memory, without a doubt. Yeah, I do give it, but this, if you don't know these 4, it will dramatic. I'll tell you that you know, even though you have them right at your resource to be able to look at them, the fact is you'll be a lot less efficient doing these problems. You'll be much more likely to make a mistake. You need to really commit these pieces to memory, and especially if you're taking calculus. This is really student knowledge. All right. Well, yeah. Not only do you want to know those, but then you really do want to know everything else on this page. And I would say that, you know, hopefully over due time, you know about half of this page. So, but I know you guys are really good at handy notes and memorizing stuff. So, well, you know, we know what you can handle. So, all right. So we will get rid of this sine of theta, and you can see that we have cosine of theta, and that's our result. Sometimes things don't simplify very well. For example, secant is 1 over cosine of theta, and cosecant is 1 over sine of theta. And as you can see in this scenario, nothing cancels, does it? And we don't, I mean, sine times cosine isn't anything special. Sine divided by cosine is, but sine times cosine isn't. So this really doesn't simplify. It's good to go just like it is. Sometimes we get an unusual answer that could translate into a new expression. For example, cotangent is cosine over sine, and secant is 1 over cosine. You can see that the cosines cancel, and you're left with, well, 1 over sine is one of the 6 trigonometric functions. Cosecant. Sometimes you can divide them. When you divide them, say tangent is sine of theta over cosine of theta, and secant is so when you divide them, you will multiply by the reciprocal. You can see that those cancel, leaving you with sine of theta. Yeah, trying to see if it simplifies. The fact is that, this expression right here factors. But all I have to do is go x squared minus 3x plus 1, and now it no longer factors. Same thing goes for some of these trigonometric expressions. Some of them simplify, some really don't. What I would like you to do is do exactly what we did, and I want you to try A, or we already did A. Do E, F, H, and I. E, F, H, and I. And when you get an answer, I would like you to come and put it on the board and show us all of your work. Be tough. We won't mock you if you get it wrong. Simple. As you look at E, you got tangent times cosecant, so sine over cosine times 1 over sine. 1 over cosine you get, which is secant. For this one, you change everything. You see the cosines cancel, but the sines don't. Sine times sine is sine squared. So in this case, you do get cosecant squared of theta, okay? But if it was cosecant of theta plus cosecant of theta, then that would be 2 cosecant of theta. So that's the difference. You can see in this situation, it looks like 1 over sine divided by cosine over sine. And so when you multiply by reciprocal, you get cosine in the denominator, the secant, and these, they all cancel and give you 1. All right, J. Sine of theta or cosine of theta? Divided by cosine of theta over 1 times 1 over sine of theta. So in the denominator, you get cosine over sine. I will multiply by the reciprocal, which would be sine over cosine. Does anything cancel? No. What do you get? Sine squared over cosine squared. What's sine over cosine? What's sine squared over cosine squared? Okay, we have sine squared over 1 times, hi there, cosine of theta over sine of theta times 1 over sine of theta. And you can see the sine squareds cancel, leaving me with no. So here, instead of, so divided by sine of theta over cosine of theta, instead of dividing by sine over cosine, they multiply by the reciprocal, and that's what they came up with. Good point. No, if you would look at, say, this example right here, this is very common. And this is where you don't want to mess around here like this on the test. You won't make any progress. Some people will take this problem right here, instead of taking sine over 1 times 1 over cosine, here's what people will do. 1 over cosecant of theta times 1 over cosine. Does that help you at all? It doesn't. The goal is to turn it into terms of sine and cosine. Look at what you did. This was in terms of sine. You just took it out in terms of sine. You know what I mean? And that's a very common mistake. But if it's already in terms of sine or cosine, leave it alone. Don't change it to something else. Change it to something that would benefit you moving forward. Okay, let's go. Oh no, Mr. Gantz made it more difficult. Ugh, anyone who does that must have been in a bad mood when he made the notes. Okay, so a lot of people, when they see this, they will distribute, and they'll get cosecant of theta minus cosecant of theta times cosine squared of theta. And now it looks really ugly. Like you thought it was bad to begin with. Now it looks really bad. Okay? So I don't like this option. Any thoughts? Sounds good. Sounds good. Write your own book on math and do about it. All right. So I would buy it too. Okay. All right. Um, this is important right here. In fact, I remember something. Don't write this down, but I'll bring it to the page. I remember this. Do you remember that? Watch. I just subtracted the cosine squared. And so I can replace this with sine squared. Is that nice? So flip to your back page. Wait a minute, that's not movement, that's subtraction. That's second grade. All right, here we go. So, as you notice, sine squared plus cosine squared is 1, which means that if you subtract the sine squared, you get cosine squared is 1 minus sine squared, which is what I have right there. I also have sine squared is 1 minus cosine squared, which is right there. Again, you get the sheet on test, but if you constantly have to look back at it, the fact is that you're not going to be very efficient, okay? These are things you want to be able to look for without having to look at the sheet. So you really do want to try to commit these to memory. I just put them all there, so this is to make a flashcard for something you could really take a glance at. Given this one formula in 5, if we divide it through by cosine squared, we get then 6, which is 1 plus tangent squared is equal to secant squared. And again, that can change all sorts of shapes and forms. If we divide through by sine squared, we would get this formula, number 7, and it can also change shape and form. So we're going to use those in order to insert some pieces that will simplify. In this example, instead of 1 minus cosine squared, what do we write? Sine squared. We substitute that in times cosecant. Hey, now this looks like a problem from the front page. I know how to do the problems on the front page. I write them in terms of sine and cosine. What is cosecant? Over sine. What happens? One of the signs cancel, leaving me with just sine of theta. Oh no. The next one looks really bad. But it's a secant squared and it's a 1. That triggers something in my brain. I remember something says secant squared and 1. Hey, it's formula number 6. Secant squared and 1. In fact, if you subtract the 1 from both sides, you get tangent squared is secant squared minus 1. Look at that. That is useful for substitution. What I will do is I will plug in tangent squared. And I get cosine squared of theta times tangent squared of theta. Hey, that looks like a problem from the front side. Sweet, huh? And secant squared minus 1 over sine squared. What do you put in for secant squared? Now it looks like a problem for the front side. What do you do? Multiply by the reciprocal. Whoop. What about the next one? Any thoughts? Can I show you third hours idea? Totally illegal. We ran over, we got Miss Nelson, we brought her over. There were tears. Yep. Okay. If this was x squared minus x squared times y squared, you might think about taking out a common factor. What's the common factor? You get x squared times 1 minus y squared, correct? So what's the common factor between these two? If you factor it out, you're left with 1 minus sine squared of theta. Hey, now that looks like a problem that we just did. Just like x squared minus x squared y squared factors to this will factor to tangent squared times 1 minus sine squared. If I distribute through, what's tangent squared times 1? Tangent squared. What's tangent squared times sine squared? Okay. All right, what can I insert for 1 minus sine squared? Well, tangent squared can be rewritten as we got sine squared of theta over cosine squared of theta times cosine squared over 1. Cosine squareds cancel, leaving you with. Now, it just so happens that it works out to be the same thing as if you cross out the tangent squares. But trust me, that is not always the scenario. And if you just wrote sine squared on your test, canceling these out, that would give you 0 points. So you must support your work, or your answer will be wrong. All right, last two here. What do you think I factor out here? Factor out a sine squared. And I get secant squared of theta minus 1. Good. I remember that secant squared. What can I substitute for that? Wonder if something would cancel for that. Doesn't look too good, does it? So this really doesn't simplify, so it looks like this is about as good as it can be. So just realize sometimes it's not going to simplify as far as you would like it to. We're not going to write it as sine to the fourth over cosine squared. That doesn't really help us at all. I think that's probably the best one. Yep. No, because this would be sine to the fourth, right? you got this on the test and you then wrote it in that form, I'd probably give you full credit for expressing it that way. But this doesn't really help us at all. That's probably more useful. All right, last one. What do I factor out? What do you have left? What's 1 plus tangent squared? What is the relationship between cosine and secant? They are reciprocals. What happens when you multiply two reciprocals together? You get 1. So you can see that you are going to get 1. If you don't see that, then sure, go ahead and write it out. But if you recognize they are reciprocals, then you can just say, that we want. As I write it out, you can see that they cancel to equal 1. Okay. So there you go. There's your introduction to Chapter 7. It's going to be a great time. Make sure you stay on top of your work. Wonder if those band people watch the video, huh? Should we say that? They don't have time to. Oh, they don't have time, except for their 22-hour ride on the bus, huh? 25. Oh, then they're using up data. Well, what else would you use data for other than watching pre-calc videos? So what should we say to the band people? Anything? We hope you have fun. What else? We miss Kayla. What else? Jack, you should bring us treats. We want treats, Jack. Jack, you're banned till you bring treats. What else? Kelsey got off her braces. Oh, she's smiling. It's great. Insert a picture onto a video. You can't do that, Ryan. You can't do that. Oh. Ryan, stop being mean to Emma. Oh, knock it off. How about Brishi? Is she on the trip? Brishi, I'll be honest. With how loud you are in class, it's nice to have a break. All right, have fun, kids. There's your assignment.